Good afternoon and welcome to Niall Con. Next year we are going to replace all sessions with a picture of my face and some pre-recorded. This talk will be a bit shorter than the slot suggests because I ended up cannibalizing some of the material for my talk earlier. So maybe there'll be questions, maybe not, but I won't overrun very much so. Okay, there seems to be some kind of conference thing that we're attending. It seems to be called SREcon. I wonder what that is. It'd be pretty rad if we could figure out what that was. So there's some prior art in this area, which is fine. But actually, maybe it's a bit long and complicated. We're looking for a shorter summary of what it is that we're doing. For the purposes of this talk, I will say that SRE is engineering and operations reunited. Friends reunited, right? So in this way, engineering acknowledging that the domain of operations is an entirely valid domain within which to engineer, and operations acknowledging that engineering is something to bring to the running of systems, and so on. Well, everyone's happy. Well, okay, not everyone's happy. I know people have different opinions, different working experiences, environments, etc. I'm not going to dismiss any of that lived experience, but I'm simply going to define this talk over my current best one-line summary of the profession. Note, this is not the best one-line summary ever. It might not even be the best summary today. But for the purposes of this conversation, we're talking about a reunification of engineering and operations in the computer world, which itself raises an interesting question, which we'll get to in a few slides. Another way to think of it is there's this thing called a full stack. Now, back in my day, this didn't mean 90 million varieties of JavaScript. It meant hardware up to JavaScript, okay? I guess I'll have to come up with a different term. So it turns out you can model how computers work with this kind of layered architecture, right? So there's layers of abstraction encompassing the behavior of particular subcomponents, and they talk up and they talk down, and occasionally if you get your engineering wrong, they talk and skip a few levels or refer to each other or something. But I'll again assert, for the purposes of this conversation, that classic system administration work goes from hardware to libc. I certainly was crimping cables back in the day, and I certainly knew when libc was messing up. And mostly product folks went from JavaScript to libc or libc to JavaScript, depending on your point of view. So in this view of the world, the thing that's interesting about SRE is that it actually has a lot more overlap with product software development. This is not a bad thing. This is a good thing. We do have approximately similar spreads of expertise, but we in SRE, I will use that term for the moment, are downshifted the stack a bit from product folks. So you almost never find us writing front-end user-facing JavaScript. Do find us rolling it back from time to time. Similarly, you almost never find a classical web services product suite writing a disk driver. Like, it's just not really something that happens. So it's a bit more complicated than that in the real world, obviously, but that's the basic story that we're going to tell. And with that kind of overlap, with that unification, if that's the right word, we have a question, which is, okay, what are we? Then question, if we are a reunification of these two ways of looking at the world, what caused them to split apart? Right, what were the historical forces that led to that situation? Was this a good thing? Could we prevent it from happening again? And other related questions. Because, of course, it didn't start out that way in the very beginning. So anyone know what that picture is of? Sorry? telephone switchboard. It's ENIAC, actually. Looks quite a lot like a telephone switchboard. The two women operating ENIAC. The interesting thing about the earliest manifestations of the computing discipline, of course, is the extent to which, obviously they're much simpler, so there isn't as much scope for JavaScript on ENIAC. I'm geeking out about that right now. Anyway. So mostly it was electrical engineering in the very beginning. It's like, okay, we have to stitch together these vacuum tubes in some way that's going to be able to work. With a certain amount of more abstract programming, for want of a better word, but again, it's a bit closer to electrical engineering. However, broadly speaking, everyone did everything. That full stack we saw a slide or two ago is collapsed to one box at the bottom, which is hardware and maybe, I mean, there wasn't an operating system to have a driver for, but anyway. The interesting thing to my mind is the extent to which, with reference to my earlier talk, the Wrens, who are looking after the Colossus systems, and also some of this plays out in ENIAC and other earlier computers as well, did everything from low-level machine minding all the way up to whatever stood for programming in those days. And broadly speaking, those roles were, as I said, held by women for quite a long while. The somewhat ironic fact is that it was the pushing out of women from these kind of undifferentiated roles at around end of World War II, which paved the way for more differentiated roles to exist, which we'll get into in a moment. I have a couple more quotes, different ones from the previous talk, about the kind of work that was undergone at around that time, which illustrate the point, I think. Machine work, quote, machine work, and the theory and skills it required was an integral component, both intellectually and functionally, of the code-breaking process. It was not, as many assumed due to its feminized nature, de-skilled drudge work. Supervisory cryptanalysts worked hard to maintain an atmosphere of egalitarian teamwork. One Wrens member who worked under Max Newman recalled that on arrival he decreed everyone working under him should call each other by their first names. Well, that's a big step in 1943. Let's not go too far. And another description stated that women tended the machines rather than more accurately stating that they operated, troubleshot, tested, programmed, repaired, and even helped to build them. So there's really quite a lot of shared stack going on in certain respects. So obviously the very earliest computers were women, people, doing computational work. And the earliest programmers were female as well. Goldstein, Hopper, Lovelace. The interesting thing is that at the end of World War II, and we moved into the phase of commercial deployment of computing, and commercial machines became more widely deployed, we also had an associated diversification of roles. The insane chaos of Bletchley Park was thrown out and replaced by a much more organized and highly stratified, siloed set of jobs, all dedicated to getting the most out of the commercial, the machines that had been deployed for commercial reasons. And it led to roles like keypunch operators, computer operators, that's distinct. Keypunch is kind of secretarial, you're putting material into the machine, data entry, and operators is kind of like cluster scheduling in that you're trying to keep the machine as busy as possible with the programs, putting them in and taking out the results, and programmers themselves. So there isn't anything in the world except that there's an international standards committee for it, and it turns out that there's an international standards committee for jobs, which will tell you that in 1968, there is a computing machine operator job. And in 1958, I think there was just a computer operator job, something like that anyway. And there are other versions in 88 and 08 and so on. But when you go back through these documents, you see tremendous diversification of roles, which nonetheless do end up being roughly bucketed into operations and engineering from relatively early on, pursuant to the split that we have when the commercial machines go out there and it's cheaper to pay for people to operate it who don't have to know all of the other things as well. Another interesting point about this, obviously the knowledge about how to run these machines much less widespread in those days than it even is now. Obviously no internet in 1950-something. So there's a lot of vendor-specific training going on, and they all end up trying to agree on what a keypunch operator means in one case versus what a computer operator means in another. And so a split emerges between people who are kind of tending the machine and people who are writing things to go on top of the machine, for a bunch of reasons, which we'll get onto in a moment. Of course, it's partially a reaction to complexity, as I was saying. In the 50s and 60s, with the emergence of operating systems and layers of abstraction and peripherals, it's important to be able to partition what's going on in order to be effective. Peripherals. So, mainframes. Mainframes had advanced things like disks and tapes and stuff like that. Mainframes required lots of different stratified roles to run them. Computer operator, computer administrator, these are somehow distinguished. Production control analysts, and a plethora of other roles. Interestingly enough, one of the jobs that started out being occupied by women in the very, very earliest days was one not too dissimilar, which is computer operator. However, at some stage, mainframes being extremely expensive to purchase. In fact, most of them weren't purchased. A lot of them were lease agreements from IBM. But mainframes being so expensive to own in some sense, there was a commercial imperative to run them for 24 hours a day. And in order to run them for 24 hours a day, you have to have people in the machine room, because it's not like on a person's desk. It's like in a thing the size of this room, and it's noisy, and it's climate controlled and all the rest of it. So you have to have people to run it 24 hours a day in order to get maximum value out of it, a strong business rationale. And so working a night shift, it's obviously hard to work a night shift and a day shift as well. And it's fundamentally at odds with familial responsibilities, caring responsibilities of various kinds, and essentially impossible to do if you're a single parent or a carer for somebody who needs significant caring. So gradually women fell out of that role because they weren't able to do that shift. And so after that wave of commercial deployment of very large machines in the 50s and 60s, in the 70s and 80s, we got further differentiation on foot of mini computers and the increasingly widely available resources, computing resources that didn't need climate-controlled rooms and could just sit on somebody's desk. Well, maybe not. I guess it depends on the desk. But for certain mini computers, it's a lot more practical to have them. They're cheaper, etc. And so systems administration as a profession kind of emerges on foot of that with the rationale or with the necessary step that operating systems have to come into being and that enough people have to adopt them to make it sense for there to be a job role for it, and so on. lots of hardware around, it needs to be run, it's cheap, and there's successful layers of abstraction between the different layers in the full stack that I'm talking about. So when we do get into the world of having peripherals and libc as was and so on, then it becomes practical to try and ignore the complexity under that stack. To understand CD, the built-in, you don't actually have to understand indirect disk block layout and so on and so forth. So, in the 80s and 90s, or actually probably more in the 90s, there was a rapid specialization in internet-related, web-related technologies and internet infrastructure, of course, which drove the creation of further differentiation, including, for example, webmaster. Anyone in the room ever been a webmaster? Yeah, cool. Anyone in the room ever been a hostmaster? Oh, cool, that's excellent. There were more hostmasters than there were webmasters. That is not something I expected. Okay. And so if we date the start of the cloud era, as I will assert, to 2006 with the launch of Amazon's AWS S3, then we also see a further emergence of specialization and yet also later generalization. Come on to that. So, coming back to why the split. So I think there are really three reasons for this split between engineering and operations that happened relatively early on and which we're correcting now. First one is complexity. A huge amount of additional stuff to master, abstraction layers led to the successful ability to partition that and to assign it to job roles. It turns out that the word profession is a very interesting word because certain things are allowed to be professions and certain things are not. For example, does anyone know why law is a profession and medicine is a profession? Yep.
You have a certified professional board, right?
Yeah, so it turns out that professions are gatekept. There are generally some kind of professional board or some entrance mechanism to figure out who is acceptable to let into the profession and who has to be debarred and so on. Computers is not quite in that position yet, maybe never, but I am interested in thinking about matters of professions and job roles, particularly in the context of SRE. Anyway, complexity is one of the reasons for this split. Another reason, of course, is commercial imperatives, coming back to what I was saying about having to run the mainframe all the time. But there's also a point about the knowledge required to successfully run a system as opposed to the knowledge required to rebuild all of it from the ground up. And as knowledge becomes more specialized, it generally attracts more money as the total number of people who are able to do that shrinks. And as your knowledge becomes extremely general, you can also generally charge a bit more for what you're doing because the kind of people who know all of that stuff are very rare as well. So there are commercial imperatives that drive the creation of job roles. And chauvinism, because you can argue that the pushing out of women of these roles and the creation of more siloed replacements for them, in particular to have computer operator ultimately coded male, paved the way for that split, which we are now correcting. The weird thing is that arguably all of these job roles emerged as a reaction to complexity. In other words, you narrow your scope to stay relevant and also to stay possible, practical, I guess. But SRE integrates again as a reaction to complexity, because it turns out that the stuff that you need to know on both sides of, we'll say, the libc barrier, and you'll know what I mean, but the knowledge you have to, the stuff you have to know in order to run successful cloud services, for example, at scale, goes across libc. You can't ignore all of that and be successful. And it plays into organizational politics as well. I mean, the SRE book talks a lot about some of the bad incentive structures that you see in quotes conventional, in quotes, companies and how they handle operations versus development. And so that broader scope requiring more knowledge, requiring to be effective in more domains, is also a reaction to complexity and is also a reaction to commercial imperatives. I would argue that we're not able, unless we adopt an SRE model or something like it, we are not able to move fast enough if we have hard-coded splits in how we do things. And thank you very much.